Hello, everybody, and welcome back to Biopsychology. And we're going to be looking at Chapter 9 today. Chapter 9 is the development of the nervous system. I can let you know right now that we are not going to actually spend a lot of time in Chapter 9. There's actually 4 or 5 main topics that I want to discuss. There's maybe 6 or 8 slides. And because this week we have to combine chapters 9 and 10, I thought that it was much more important for you to understand the information that's in chapter 10. So we're really going to fly through chapter 9 as far as the development of the nervous system goes. Okay, so let's go ahead and start with this. You'll notice in chapters 9 and 10, and specifically in 10, where we talk a lot about neuroplasticity. I want to bring it up here. Oh, and it's actually misspelled on there, neuroplastic T. Forgot an I in that. But the brain is plastic or changeable. That's what neuroplasticity means. It's plastic, it's changeable, it's malleable. A lot of research up until, I would say, 10 years ago, mentioned that in the adult brain, it really didn't change. There wasn't much of a plastic kind of characteristics to it. So if you had any kind of neurodevelopment or neurodevelopment disorders, or if you had any kind of brain damage or anything like that, it was always better early on in life because the brain is still growing, changing, and adapting. And that is still true, but there are there is research now that's focusing on a lot more of adult brains and how adult brains are still plastic to some extent. So let's talk about that. It says here that the mature brain does change and adapt. You have neurogenesis. And neurogenesis, which is the growth of new neurons, can be seen in the olfactory bulbs and the hippocampus. Okay, so let's go back to that real quick. Hippocampus had a lot to do with memory, right? And then in the olfactory bulbs, we were talking about the olfaction sense or sense of smell, right? Adult neural stem cells created in the epidermal layer lining in ventricles and adjacent tissues. Okay, so primarily where we see this neurogenesis is going to be hippocampus and olfactory bulbs. Enriched environments and exercise can promote neurogenesis. The issue here is that you want to keep healthy as you possibly can. And when we look at these disorders, and like I said, we'll talk a lot more about them in chapter 12, but when we look at these disorders in late adulthood and so on, those individuals that are still very active, maybe they're still working, or they're still driving, or they're staying active in some kind of a social group or something like that. Those are the individuals that they're keeping their environments enriched, and those enriched environments do seem to play a role in warding off, at least to some extent, some of these diseases like Alzheimer's and so on. Here you have an example of adult neurogenesis. The red areas there are that's representation of new neurons that have been created. Now, just to let you know, I mean, you look on the slide here and you see 5 or 6 red dots, and you're thinking, wow, okay, you know, not too special there. But you have to remember that up until, I would say, 8-10 years ago, this was just a fact. A fact in neuroscience was that once you were born with all the neurons that you will ever have. We know that a lot of the neurons die off, but that whole concept of neurogenesis, it just wasn't even thought of, okay? And especially in the adult brain. Okay. Effects of experience on the reorganization of the adult cortex. Tinnitus, which is ringing in the ears, produces major reorganization of the primary auditory cortex. Adult musicians who play instruments fingered by the left hand have an enlarged representation of that hand in the right somatosensory cortex. Remember the contralateral effect? That means that the right side of your brain is controlling the left side of your body and vice versa. Okay, so that's why. But what we do is we see these people that are musicians, they play a guitar and they're doing all the fingering with their left hand, and they have more representation in that somatosensory cortex for their left hand. Okay, skill training leads to reorganization of the motor cortex. So you can actually practice. You pick up a guitar and learn guitar lessons, or learn piano lessons even later in life, and you can see how the brain will change and adapt and help you learn that instrument. Okay, and then I wanted to focus primarily on just two disorders here, because autism is a very, very popular topic right now, and so I wanted to give you some vital information for it, because there's some misconceptions out there and so on. Autism comes with three core symptoms. Number one, reduced ability to interpret emotions and intentions. Okay, these are the individuals that are just they shy away from contact, right? Reduced capacity for social interaction and preoccupation with a single subject or activity. So again, you've probably heard of the kids in their bedrooms where they lay everything out just right, and nobody better touch their Hot Wheels, nobody touches their pictures or something like that. And they do have this preoccupation with keeping things very, very the way they very, very much the way they left them. Let's just say. Okay. Intensive behavioral therapy may improve the function. It's often considered a spectrum disorder also, because you have a continuum. Okay, there's so many different attributes to autism that it's hard to define just autism itself. It seems to be an autism or autistic spectrum disorder. For instance, Asperger's syndrome is a very mild autism spectrum disorder in which cognitive and linguistic functions are well preserved. So these individuals, they still might be able to do well in school, okay, and to some extent social activities, okay, or I should say do well in school with linguistics and math and so on. But it's that social component that is probably still going to be an issue for them. Okay. 1 out of every 166 births, we're looking at autism. 80% of those are affected by males, 60% are mentally retarded, 35% are epileptic, 25% have little or no language ability. So you can definitely identify. Everybody probably that I'm speaking to right now knows of somebody, a family member or a friend or somebody like that, who has an autistic individual in their household. And you can tell that, a lot of those autistic kids are not mentally retarded. You're like, well, that doesn't make sense. And they're not epileptic. Okay, and that's why, because of that spectrum, okay, they can be all over the place. Most have some abilities preserved: rote memory, jigsaw puzzles, musical ability, artistic ability, and some are extremely good at this. Okay, like your autistic savants. And they are intellectually handicapped individuals who display specific cognitive or artistic abilities. Approximately 1 in every 10 autistic individuals does display a savant ability, and perhaps a consequence of compensatory functional improvement in one area following damage to another. See, what we're looking at here is that the possibility of, that whole social interaction and interpretation of emotion and people's facial expressions and that kind of thing. Well, let's say that was all moved out of the way. You walk into a room, okay? You walk into a room or your environment, and that's not important to you anymore. That your brain doesn't have to focus on those things. Or well, this individual here said hello to me, but they sounded rude. It was like the connotation of the words, and that's all stuff that you're focusing on, that your brain is focusing on. In an autistic individual, they don't focus on any of that, okay? Or they may not. And so more mental ability goes to other things. And these other things might be artistic ability, amazing abilities, amazing musical abilities, or putting together jigsaw puzzles, things like that. These savants are amazing in what they can identify what day of the week it was on December 13th, 1932. And they'll say, oh, yeah, that was Wednesday. Okay. I have no idea if it's actually Wednesday. I just kind of threw that out there. But the genetic basis, siblings of the autistic have a 5% chance of being autistic. Okay, so that's pretty low. There is a 60% concordance rate for monozygotic twins. And so again, remember what that means is that monozygotic means that they're identical twins. So you have an identical twin who is autistic. The likelihood of you also being autistic is only 60%, even though you share exactly 100% of the genetics, which means that there has to be interaction with the environment at all, or the environment as well. And that's what that third bullet is telling us. Okay, some neural mechanisms here. They've looked at the cerebellum, they've looked at the amygdala, the frontal cortex. Remember, everything was cerebellum and motor activity, motor learning, the amygdala and fear and aggression, the frontal cortex with higher order critical thinking skills. Okay, so think of those functions. 2 lines of research on cortical involvement here. Abnormal response to faces in autistic patients. So they spend less time than non-autistic subjects looking at faces, especially the eyes. Low functional MRI activity in the fusiform face area is evidence of this abnormal response to faces. Okay? And then the possibly deficient in mirror neuron function. Now remember, we just talked about mirror neurons in an earlier chapter, and really there wasn't a lot of evidence for the humans. We had it in primates and so on, but they're still looking at, here's the ability that they have a hard time imitating. Okay. If you think about it, the way we interact with people when we go to a party or something like that, and we walk up to somebody and shake their hands, a lot of that is what we've learned. A lot of that is what we have seen. So we're imitating that same behavior. Oh, this is what it means to be sociable or social. Okay. And they don't seem to have those qualities. And maybe it's due to the mirror neuron or the deficiency of mirror neurons. Okay. So that is a little bit on our autism. The other disorder that I wanted to discuss is Williams syndrome. And this is one in every 7,500 births. Extremely rare. Much more rare than autism. Mental retardation, an uneven pattern of abilities and disabilities. So these individuals do show mental retardation. So it's not so much on that autism spectrum. These individuals are much more disabled in most cases. People with Williams syndrome are sociable, empathetic, and talkative. They exhibit language skills, music skills, and enhanced ability to recognize faces. So we already know a couple things there. This enhanced ability to recognize faces, that's the opposite of autism, right? They exhibit language skills, talkative, sociable. Well, that's not autism for sure, right? But they do have profound impairments in spatial cognition. So what we've seen here is that there's a general thinning of the cortex at the junction of the occipital and parietal lobes. Remember, occipital lobe is the primary vision center. Parietal lobe is where we have the somatosensory cortex, and at the orbitofrontal cortex. Okay, so that's going to be orbito means it's right around the eyes of the frontal cortex. And elfin appearance, here's another characteristic here is that they oftentimes are short, small, upturned noses, oval ears, and they have broad mouths. That's just a characteristic of this syndrome. One thing that I don't think it was in the slide that's associated with autism also was the square ear that you read about in the book. Oftentimes these people have square ears. Their ears are also lower on their face and shifted back somewhat. But other than that, they don't carry any other real outward manifestations of a syndrome. I just wanted to introduce you a little bit to the idea of neuroplasticity, and then talk about a couple of those disorders, since they are um, something that you might read about often, especially in the case of autism. Okay, so that's chapter 9. Thank you. Goodbye.